Okay, in this video I want to show people how they could get into knife making for a relatively cheap entry-level price. So I've got some different components here. Here you see I got a PID controller. These run you about $30. And these hook to a K-style thermocouple, which I have ran in through the back there. I'll give you a little shot of that. So you see here, there's the thermocouple, got it running through some soft fire brick and right into the back of the forge. So the body of the forge here is made from a paint can, very cheap, but don't let that fool you, because the inside is what matters. It's not the shell that you make the forge out of. Now, granted, if you make it out of, 1/4-inch steel pipe, yes, it's going to hold up and last longer. But if you're looking to get into knife making for a very inexpensive price and a very easy build, this is definitely the way to go. This will hold up for quite some time. And like I said, it's the lining that really matters. So what I have these lined with is some ceramic fiber. It's 1 inch of ceramic fiber, 8 pounds, Morgan thermal ceramic fiber, very high quality stuff. On top of the fiber, I've used a product called Kastolite 30 Li+, and it is probably the best insulating refractory to use in forges. Don't take my word for it. Go digging around in some blacksmithing forums on forge builds, and most of the people you will find say that this is the highest quality stuff to use. So the the Kastolite 30 Plus is about a 1/2 inch thick layer is what I use. Ideally, you could go a little thicker than that, but I didn't want to cut down on my chamber size. So this right here, this is just a little piece of fiber I've thrown in there to get it up to heat more efficiently. You can see my workpiece is only about, I think it's 3/4 inch pipe, or sorry, 3/4 inch steel rod. So I didn't need a big opening for that, and I'm only running at, I'm less than 3 psi over there. I'm about maybe 2.5 psi, and you can see my temperature here is climbing up to, I'm close to 2,000 degrees, 1943. It's holding pretty steady there. Good forging temperature. So the gas orifice in my sidearm burner is 0.025, so it's pretty small. I'm running at a super low psi. It's quiet and it's hot, and it's an even heat because that Kastolite 30 refractory will absorb all that heat and distribute it evenly. So your whole forge inside will be, once it comes up to temperature, will be glowing orange. If I need a higher temperature, say I want a forge weld, I can just increase my fuel pressure, and this thing will start climbing very quickly. So if I want to go up to, say, there I'm at 6 psi, and in no time at all, this thing will be over 2,200 degrees. And that's still very, very efficient, mainly because how well it's insulated and how small the chamber is. So that's the secret. If you don't plan on making knives that are, this will accommodate knives with the opening without that fiber is about 3.5 inches. So most of your knife blades are going to be smaller than that. So you want to go as small as you can to make it as efficient as you can. If you need something bigger, just remember you're going to be using a lot more fuel. You're going to probably need a bigger propane tank because your propane tanks are going to be freezing up on you. So this is for a beginner knife maker. to get into the craft, this is what I recommend. Over here on this side, I have a 50 caliber ammo can. It's lined the same way, 1 inch of fiber with another about a ½ inch of Kastolite 30. This one I have, it's the same sidearm style burner, which can be put in vertically. And if I take this fitting out, it's just a Venturi burner. But what I've done is I've added this elbow, and I put a gate valve in over here to allow air to come in. And so this is what they call a forced draft burner. So this will give you precise control on your air-gas mixture if you want an oxidizing, neutral, or reducing environment inside there. Now these burners naturally are designed to give you a slightly reducing environment. So I don't know if you could see this, but you can see, yeah, at this angle you can see the dragon's breath coming off there. That tells you you got a nice reducing environment going on in there, and that's about perfect. That's what you need. But if you want real precise control and even more efficiency, that's one thing about the forced draft is you could run these more efficient than you can just the naturally aspirated Venturi style burners. So I would say 50% more efficient, but with small chamber sizes like this and you got them choked down, it's going to be efficient either way. Now if I had a larger chamber, it would be really important to have the forced draft style. But I just had this set up because I want to show people how easy it is to convert a Venturi style burner. And so you can just take this out, take this fitting off, and plug this into the forge, and you have your normal Venturi style burner. You can take it on the go. You can see I made these forge stands. I didn't have to spend a lot of money on those either. I made them out of pipe, plumbing pipe. They're super sturdy. They've got 4 flanges down here that can be bolted down. You can add extended legs here of any length you want to make them as high or low to the ground as you want. I got this set up sitting on a cheap Harbor Freight welding table. Works very well. And these sidearm burners work very well also, and they're not real expensive to build. Here you see I've got a pressure gauge on there. Got a pressure gauge on here. Now you can add a valve right here if you want quick control, but you have a valve on your line here where you can control the fuel pressure. So see our temperature still climbing there. It will go up over 2200 degrees. If you want to get it up 2300, you can add a little more pressure to it, but this is plenty hot enough. I can give you an idea of what kind of heat color we have. Maybe put my glove on. I don't want to burn myself. And so you can see there, this is an old piece I've used just for testing several times. You can see how much scale's on it, but that's only because it's been in and out of this forge multiple times without me cleaning it. So like I said, they have the sliding tool rests on here, and then I have the hard fire brick front and back porches. Makes it pretty nice just for resting your stuff on. So if you have any questions, let me know. If you'd like to try building one yourself and you need advice, or if you're looking for material, or if you'd like me to build one for you, I do have an Etsy shop where I sell these. You're welcome to get on there and just purchase one. I ship out these ammo can forges here. They're $165 with the Venturi burner. and the high pressure 20 psi regulator. Pretty much everything you need. I also will provide you with the refractory if you need that, or if you want to convert it to a 4-strap burner, I have the parts to do that. So let me know if you have any questions. I'd be more than happy to help. Thanks for watching, and you see our temperature is over 2200 now at 6 psi, and I think I mentioned that is a 0.025 gas orifice tip delivering the fuel. So you can do the math on that to find out exactly how efficient or how long a standard barbecue size tank will last, as long as you know the fuel pressure and the gas orifice size. So I can tell you though, it's super efficient, and it will, you get about as much heat out of this little paint can forge as you want. Oh, one more thing real quick. Some of you might have questions about the this forge has been running for quite some time now, probably at least 10-12 minutes, and I'm going to shoot the side of it with my heat gun here. So if you can see that, I don't know if you... So we're right about 500 degrees, a little over, depending on where I take my here it's about 480. So about 500 degrees, and when you think about it, the inside of that chamber is over 2200 degrees. So that's not a lot of heat loss. And that can, or the paint can or the ammo can, should hold up for quite some time if the temperature on the body of it is only hitting 500 degrees. I do have I paint both of them with 1200 degree paint, which you can pick up at any hardware store. You just get the high temperature black paint. You touch it up every once in a while if you want to keep it looking good, but these will hold up if built right for quite some time, and you don't have to spend a fortune. And believe me, these are much higher quality than a lot of the forges for sale that are more expensive. So I've been doing this a long time, and for an entry-level forge, these are definitely the way to go. So like I said, let me know if you have any questions. I'd be happy to help, and thank you for watching.